So given this table of values, I want you to determine, first of all, what's the difference between the x values or the x coordinates. Okay, so what we can do is we can take consecutive coordinates, or we can take, we can jump across like this. I'm going to say there's a change in x is equal to +2. So I'm going to say +2. Okay, and I'm going to say then as long as I make my change in y's the same amount, okay, so oops, this is wrong here. I need to skip one here like this. And I have a change in y is equal to +10. Now I could have used 1 and 5, but notice that it doesn't make a difference because when we actually, this is a ratio of change, and we can use any ratio. We can use a large proportion ratio, or we can use a small proportion ratio. It doesn't matter because we're going to be comparing this as a ratio of change. So the relationship between the x values and y values is going to look like this, where we really should maybe say where it starts. Okay. Well, we need to know where it starts. So I'm going to use this proportion of change, okay, to go backwards. Okay, so I'm going to go back to 0. X is 0. So that's going to be -1. My change in x equals -1. What does the change in y have to be if I go backwards like this? So my change in y, if I go +1, I'm going to go +5 for the y. So if I go -1, so in here I go, the change in x is -1. So the change in y then must be -5. So I'm going to go 5 to 0. Okay, so when I talk about describing this in words then, we need a starting point, and our starting point is a good starting point always to use is when x is 0. So I'm going to start at 0. So I'm going to start at y equals 0, and then I'm going to go up by so we can describe now the ratio of change, how we increase this, or the angle that we're going to go at, or the slope. So I'm going to go up like this. I'm going to go up by +10 for every, actually I'm going to write it like this, go up by +10 on the y. Maybe I'll make that on y for every +2 on x. Okay, now we can change this. We can say that this is +1 and +5. Okay, we could describe it like that. Okay, and make sure that's clear. +5 on the y for every +1 on the x. So then we could maybe put this into a relationship, into an equation. So what would this calculation look like? Okay, so the y value is going to be calculated by, well, we're going to start at 0, and then we're going to increase by groups of 5. Well, groups of 5 really means times by 5. So I'm going to write it like this. 5 to 1, okay, which is really a group of 5, times x. Or just y equals 5x. Okay, and that relationship then is going to graph like this. So we start at 0, 0. I'm going to go up by 1, 2, 3, 4, 5, like that. And then along the y, we're just going to go up by 2. So 2, 4, 6, 8, 10. Okay, 12, 14, 16, 18, 20. Okay, so we're going to scale the y like this. And we're going to start at 0, 0. We're going to go to 1, 5, 2, 10, 3, 15. And again, notice that's tracking out a straight line. Okay, and 4 and 20. there's our straight line pattern. We can see our slope as changes in the graph. So there's our plus 5. Okay, and here's going to be our plus 1. There's our ratio of change. And that ratio of change ends up being the multiplier. So this ratio of change of 5 to 1 really is our multiplier, or constant of multiplication. It's going to end up being 5x. So there it is. There's our relationship in a table. We put it in a graph. To be able to describe the relationship, what we did was we went back to 0. Now we didn't have to start at 0, but that's always going to be our first choice if we can, for now. Down the road, we're going to start wherever it's going to be convenient for us, but for now we want to start at 0.